G'day Year 7s and welcome to exercise 10F. We're getting there, we're nearly there guys. A couple of weeks left, we are winding down, but what we are doing is very important, so make sure you are paying attention. Okay, so wake up, get yourself freshened up if you need to. So you're focusing on this, and let's get this done. Exercise 10F, equations with brackets. Now, if you remember earlier when you had an equations with brackets, and if, okay, let me give you a quick one. X plus 3, that's a really poor 3, but anyway, equals 12. If that last number, if that 3 can divide into that 12, you move that 3 first. All right, but we don't always get that. We might have a problem that looks like this. So 3x plus 3 equals 14. Okay, if you try and divide that 3 over to this side, you're going to end up with a decimal. And we don't like working with decimals if we can avoid them. Okay, so you've actually got to expand these brackets. Now we have done a little bit of work with expanding brackets. Okay, and that's using the distributive law. All right, so basically what the brackets mean is that everything inside the brackets, and I might go with what I'm going to do here, bear with me. Okay, open this up. So let's do that problem I've got 3, then in brackets x plus 3 equals, does 14 work? Not really, 15, 16, no, it doesn't matter. All right, doesn't matter. Just say it equals 16. All right, actually no, we don't even need that. We're just looking at, it's okay. I'm under control, I'm a professional here. Okay, let's just look at the brackets. So if we're using the distributive law, everything in these brackets, this is what the brackets are telling us, everything in these brackets gets multiplied by 3. All right, so just say x was 5 in this case. What we've got to actually do is add 3 to that 5 and then multiply that answer by 3. So you'd have 5 plus 3 is 8, so 8 times 3 is 24. Okay, now if you've got to expand the brackets, that means that you've got to actually multiply everything inside the brackets by whatever is out the front. So the first thing you do is multiply that at the start. Okay, so this 3 multiplied by the x. Then in the middle here, you write everything else that's in the bracket. So then I'm going to write the plus 3. Now that's not the end of it, because all I've done here is multiplied the x by 3. I haven't multiplied this other number, this 3, by the 3 yet. Okay, so to do that and to make it simple, and so I avoid mistakes, I've got to make sure I write the brackets part all together, and then I'm going to multiply this last part by 3 also. Okay, and now what I actually might do, I'm going to get rid of all that because it's ugly just having all these 3's. So bear with me. So I might have, I'll start with a 3 there, x plus 6. Okay, so again we multiply whatever is at the start. So 3. So what you see there, 3, put a multiplication, get rid of the brackets, put a multiplication instead, then continue writing whatever is in the brackets, and then you multiply by whatever is out the front at the back. Okay, so 3 times x plus 6 times 3. So both the x is being multiplied by 3, and the 6, the plus 6, mind you, is being multiplied by 3. So that is the distributive law. Okay, so yeah, if that last part can't be divided by the number that's out the front, if you can't swing that out and divide it and it doesn't go in a hole and you don't end up with a whole answer, you've got to actually expand the brackets out and then solve it from there. Okay, yeah, so that's the distributive law. And if you get like terms, and remember what like terms are, again we're going back to some algebra we did earlier in the year. You've got to go by the pronumeral. Okay, so 3xy and 8xy are like terms. Okay, and why are they like terms? Because the pronumerals, the letters, are exactly the same, but the order doesn't matter. So I could have 6yx, for example. Now, is that a like term to these guys? Yes, it is. Yes, indeedy. Because x and y are x are exactly the same letters there. All right, but if I had a 5, whoop, I don't want that. Whoop, making a mess. 5xzy. Okay, that is not a like term because we've got x, z, y. These guys only have x and y in them only. So they are all like terms. Okay, that's a like term, that's a like term, that's a like term, but this guy isn't because of the z. Okay, it makes it not a like term. Okay, so like terms mean when you're looking for like terms, you've got to look to see if the letters are exactly the same. The number doesn't matter. Number's got nothing to do whether they are like terms or not. Okay, all that happens there, just say if I had 3xy plus 8xy minus 6yx is that, yes, they're all like terms. That's a like term, that's a like term, that's a like term. So I can add and subtract them. All right, so 8xy plus 3xy means I get 11xy. Whoops. 11xy minus the 6yx. So now I can 11 minus the 6 gives me 5xy. Okay, so that's all that the like terms means, that I can add and subtract them. Okay, so it's important that you remember that. We did that earlier in the year, so it is really important that you actually remember that. All right. Okay, I'm not going to worry about, no, actually we will go through these. So like terms are terms that contain exactly the same variables, so the pronumerals, the letters, and then you need to collect them to simplify expressions. So for example here, 3x plus 4 plus 2x can be simplified into, because like term and like term, and you remember the sign out the front, so it's a plus 2x, so it's 3x plus 2x gives us a 5x, okay, and then this plus 4 is tacked on at the end. Okay, so you've simplified that expression into this because you've got two like terms, the 3x plus the 2x. Okay, so you add the numbers together and just put the letter on at the end. All right, so 3 plus 2 is 5, and then so it's 5x. All right, equations involving brackets can be solved by first expanding the brackets, okay, which is what I did here, okay, expanding the brackets. All right. And then collecting like terms and then solving from there. So there's a little bit extra work to do in these guys to get them done. So let's, all we're going to do here is expand the following. All right, so what I want you to do is actually pause this video. I want you to do each of these problems and expanding the brackets. If you need to go back to what I did here, all right. Actually, I'll get rid of that arrow because I'm going to go this way with that arrow. All right, so that's the first thing. Whatever's in front goes first, and that goes second, if I could draw it. All right, so that is a 2 in there. So you multiply the front by 3 first, and then whatever is at the back, you multiply that by 3 second. Okay, so I want you to actually pause the video, and I want you to expand. That's all you got to do. Not have to solve anything, just expand the brackets. Okay, so don't make me look silly or sound silly here. Make sure you please pause, get a piece of paper, pick up a pencil, and see if you can expand each of these brackets and each of these questions. Okay, off you go. Bye-bye. Okay, welcome back. Hopefully you paused. Let's expand these. All right, so this first one, all right, and I don't know, this might be a good way for you to go, is that you write the bracket section without the brackets. And then all we're going to do at the start is, okay, I've got the 4 at the front, so I've got to multiply that at the front, and I've also got to multiply that guy at the back. Okay, so now we follow our BIDMAS, we do multiplication first. Okay, so 4 times x is 4x, plus 3 times 4 is 12. I've just expanded the brackets. Hopefully that is what you got. Okay, that easy. Draw some lines in here. Talking very quickly, I don't know why. But anyway, let's continue on. So again, I might just write, this might be a good way, I've just sort of thought of this now. Q minus 4, write your brackets part without the brackets. Now the 6, let's multiply the front by 6. Let's multiply the back by 6. 6 times Q, 6Q, minus, okay, don't forget the minus, 4 times 6 is 24. Done. I've expanded the brackets. Last one, same deal. Let's write the brackets part without the brackets. 3a plus 4. Let's multiply the front by 5. Let's multiply the back by 5. Okay, so 5 times 3a. Now, when we talk about like terms, when we spoke about like terms, when you're multiplying and dividing, the like terms don't matter so much. Well, they don't matter. Okay, it's only adding, subtracting that you have to worry about like terms. So in this case, I've got 5 times 3a. So all you do, and again, we've done this stuff. You've got to try and remember it because it really is an integral part of this stuff. Again, with algebra, is that you multiply the numbers together and you tack the letters at the end. So 5 times 3 is 15a. The a just drops down, plus 4 times 5, which is 20. I've just expanded the brackets. Okay, so that is expanding the brackets. Hopefully that makes sense to you. Go over it again if you need to. Write the brackets part on its own, then put the front part of the brackets, what you're multiplying everything in the brackets by, at the front and the back. Seemed to work pretty well with me. I was pretty happy with it. Next part, simplifying. So let's look for like terms. All right, and usually, again, I like to put the like terms together. So I'm going to rewrite the equation, making sure when I move anything, whatever sign is at the front of the term, or the number, or whatever it is, has to move with it. So I've got 2x there, I've got another like term with x, they're exactly the same letters, so I'm going to move this plus x up next to it. So I've got all the like terms together, and then the plus 5 can tag on at the back. 2x plus x is
3x plus 5.
Okay, so 3x plus 5 is sitting in there, and that's it. That's all you got to do. Next one is 3a plus 8a, and we've got a minus 2a. All right, so here's our like terms, all got the same letters in there. So let's do this. I'm going to rewrite this. So 3a plus 8a minus 2a. Okay, and then our last parts, the plus 2 and the plus 5, have to go in at the end there. Okay, so 3a plus 8a gives us 11a. I'm just going to do one part at a time. Minus the 2a there, plus the 2 plus the 5. 11a minus 2a is 9a plus, and then I can add these guys, 2 plus 5 is 7. So 9a plus 7 is what that simplifies to. Hopefully this is making sense to you. Okay, let's do some actual problems here. Okay, solve each of these equations by expanding the brackets first. All right, so I've got 3. So let's do this. X plus 2. I multiply the 3 at the front. I multiply the 3 at the back. Equals 18. 3 times x gives me 3x plus 2 times 3, which is 6. And then equals 18 at the end. All right, so I'll just put that part to here, this part to there, and then the 18 at the end. Now we solve it like all our ones you've already done. All right, now this is asking you, you will notice that 3 can actually divide into the 18. Okay, so normally I'd say, yeah, divide the 18 by 3 straight away, then you don't have to worry about expanding the brackets. But the question is asking us to solve these equations by expanding the brackets first. So we're answering the question that it's asking, okay? So now we've got to solve for x. We've got x on its own. So the first thing we've got to do is move this 6 from this side over to this side. So we're left with 3x equals 18 minus 6. So 3x equals 12. Then we're going to move the 3 from this side to that side. It's multiplying on that side, so it's got to divide on this side. So we're left with x equals 12 divided by 3. So x equals 4. There we go. If I substitute that in, I'm not going to write this up. So instead of x, I'm writing 4. 4 plus 2 is 6. 3 times 6 is 18. I know I've got it right. Wacky do. Cool bananas. There's another one. All right, let's do this one. Again, don't get confused because it is flipped around. You still follow the same procedure. You just apply it to the other side. So the 7 equals can be written first. Then I'm going to leave a bit of space. So I'm going to write my 4q minus 3. I put out my 7 times at the front and my times by 7 at the back. So now 7 times 4 is 28, and then I put the q after it. Okay, minus 3 times 7, which is 21. And don't forget my 7 at the front there. So now I've got q on this side, on the right side, so I'm moving this minus 21 from this side in between the 7 and the equal sign this side, this time. So it's 7, it's minusing this side, so it's got a plus 21 on this side, equals 28q. 7 plus 21 is 28, equals 28q. Now we're going to move the 28 from this side over to this side. Oops. And remember, it's going in between again, so it's going to be 28. Now the 28 is being multiplied with the q on this side, so it's got to be opposite, so it's got to divide on this side. Equals q. 28 divided by 28 is 1. So q equals 21. And if I wanted to, I'm going to flip that around at the end. Q equals 1. Let's substitute it in. 4 times 1 is 4, minus 3. 4 minus 3 is 1. 7 times 1 is 7. Again, whack, do. Got it right. On fire. Don't know why I'm talking like a robot, but let's stop, hey? Alright, so a little bit more involved here. We've got to expand the brackets, but we've got some other stuff. But let's just write everything down. You write all parts of the equation and you just work through it bit by bit. Okay, so my first tip is that I'm going to write, I'm a bit worried I'm going to run out of room here, but let's try and write a little bit conservatively. So the b plus 5, make sure I write the times 3 at the front. times 3 at the back. So I've done that part. Now I can't forget this plus 4b. Don't forget, because again, a lot of students would just go, well, that's what Mr. O'Donnell told me to do it that way, and then we end up forgetting parts of the equation. So a lot of people, and I've seen it, won't write this section. They'll just do that part. So don't forget your plus 4b there equals 29. Now I'm not looking at that one. I'm looking all here. This is the only part of the line I'm looking at. So I've got to multiply all these parts out. So 3 times b gives me 3b plus 5 times 3 is 15 plus the 4b is still there, and that all equals the 29. Just keeps dropping down. Now I've got 3b plus 4b, so again, always a good idea to put your like terms all together equals 29. Okay, so 3b plus 4b, 7b plus 15 equals 29. Now I'm going to shift this up here. I'm going to rewrite that. Yes, and these do take a while to solve, and they do take a few lines, and be patient with it. So first thing I'm going to do here is I'm going to move this 15. So the 15 is now gone from the left side, so I'm left with 7b equals 29 minus 15. It was plus 15 on this side, so now it's going to be minus 15 on this side. So 7b equals 29 minus 15 is 14. Now I'm going to move this 7, which is being multiplied. So on the other side, it is going to divide by 7. So b equals 14 divided by 7 is 2. Let's substitute that in if I can see. Yeah, it's going to be a bit of an effort. I'm not going to actually do that because, well, you can do that yourself if you want to check it. I'm very confident I am correct on that one. But you can well, let's do it. Okay, b is 2, so 2 plus 5 is 7. 3 times 7 is 21. 4 times 2 is 8. So 21 plus 8 equals 29. There, told you, got it right. Cool bananas. Alright, so that is all. Again, yes, these do take a fair whack to get through and to show all the working out. And at this point, yeah, I'd like you, again, you model this working out. This is exactly what you show. This is exactly how you should be doing it. I'd even be happy as you work out what you're moving is to cross them out like I've done here to show, well, if that's gone, what is left on the left side or the right side, depending on which way you're working. Yeah, it's a good way to probably show that, yeah, what you're actually doing there. Hopefully that makes sense. We'll work through this stuff, and yeah, it's important you do get this right, because if you can understand this, yeah, going through to 7, 8, and 9, and no, sorry, 8, 9, and 10, you'll just find this so much easier to understand and learn. All right, so that is the end of this video and this week's video. So hopefully it all has all gone well. Make sure you ask any questions if you're not sure. Again, problem after problem after problem after problem after problem is the only way to approach this stuff. The more problems you do, the better you get at it, the more confident you get at it, and the better you understand the process. Okay, so it's really important you do that. Thank you guys. We shall see you in class. Bye bye.